Hi, my name is Tom Coolidge, and I'm Esri's Pipeline Industry Solutions Manager. I am facilitating today's webinar along with my colleague, Jeff Allen. Jeff is Esri's Global Pipeline Practice Lead. On behalf of both of us, welcome to our focus on A New Era Begins in Pipeline Network Data Management. These are really exciting times for GIS in the pipeline industry, and I think you'll find our time together today to be interesting, informative, and helpful. Now, please welcome my colleague, Jeff Allen. Jeff?
Thank you, Tom. Thanks everybody for taking some time out of your busy day today. This is a really exciting webinar for us. This is the culmination of a lot of vision and a lot of hard work at Esri. I've been here for about 4 years now, and a lot of this work even predates my coming to Esri. But basically what we're going to show you today is the sort of the final rendition or the final version of a vision that we had to bring together a couple of different pieces of the Esri technology and bring them together in a seamless fashion for the pipeline industry. And the reason this is so important and the reason that our customers have been asking for us is because as we have regulatory pressures, as we have pressures on the business to be able to do more with less, the fundamental premise behind that is we have a solid understanding of what the assets are in the field and how they operate. So not just points on a map, but actually the detailed infrastructure behind that, the detailed digital twin of those facilities and how they interplay with each other. And so what I'm going to show you today is how we've been able to substantiate that vision in the Esri platform and really bring that to life. But it really started with this vision of being able to have a fully seamless connected network of pipes, regardless of where the user was in the supply chain. So we have, different needs in the different parts of the supply chain relative to GIS and data modeling. We've got our traditional transmission or midstream segment that has relied heavily on linear referencing to be able to make their GIS data models work. We have the upstream, both onshore and offshore gathering lines, have a lot of use cases for connectivity, and have traditionally migrated their data into a linear referencing system, but maybe have lacked some of the network and connectivity capabilities that they would like. And then we have the whole downstream supply chain, which has been traditionally a network-based solution, not highly reliant on linear referencing and the things that we do in the midstream. And then all along this supply chain, as we go inside the fence, we've got different needs for modeling pipe and connectivity inside pump stations and inside facilities. And as we start integrating the GIS with the larger enterprise systems, a lot of the work that we do and a lot of the assets that we map inside the GIS that are inside the fence have connectivity to other systems in the organization. So it's very important that we have this. And then again, be able to make sure that we can seamlessly manage this, not in 3 or 4 different systems, but in one single enterprise geodatabase with all this information and talking together. And that's what I'm really going to strive to show you today. So the manifestation of that, how we were able to substantiate that in the platform, really comes to life in 2 pieces of technology that we have. One is the pipeline referencing, ArcGIS pipeline referencing, which is the linear referencing tool. And the other is the utility network, which is where we get our connectivity from, right? So be able to manage all that pipe from the wellhead to the customer meter and everything in between in a single enterprise geodatabase. We're now fusing these 2 technologies together. So now at version 10.8, we can have pipeline linear referencing and the utility network now integrated and working together in a single enterprise geodatabase. So what are the advantages? What do we pick up if we're a linear referencing organization when we bring in the networking capabilities? Well, obviously the mapping, right? To be able to go down and map to that next level of detail within the facilities, both in 2D and, as you'll see on the far right, 3D as well, which I'll show you. To be able to have alternate views of that data, how to produce schematics and line diagrams for that data as well through that connectivity model. We have a thing called component views. So as I drill in on the GIS data, I can open up containers and see more details inside of facilities, all connected together. Run advanced analytics. How can I do tracing about isolation tracing and flow and look at pressure systems? I can do that through the utility network, as well as looking at both historical and planned views, right? So this idea of a life cycle status for these assets. So they're either proposed, in service, or retired, and have the whole system react to that life cycle status accordingly. So as we make this switch, as we start to integrate these new tools, there'll be a change in the philosophy, a change in the underlying technology that you need to be aware of. Historically, these tools have been based on the client-server architecture. So we have a single desktop or a set of desktops that are connecting directly to the underlying enterprise geodatabase and editing data inside of there. Both ArcGIS pipeline referencing and the utility network now work on this web services architecture, which means two things. I open up more accessibility to the underlying data for editing. So not only can I edit from the desktop, but now I can edit from a web application or a connected mobile device. But it also brings more power into the server. So at that web services architecture, now I have a rule base. So I can actually add business logic. And as that data enters the system, I can make sure it validates and passes a set of rules before it's made available to the rest of the organization. Now, inside of these data models, there's going to be a set of core objects or core information models that each of these tools is going to maintain its portion of the model. So for those networked utilities, we're basically going to be building into the model all the fittings under pressure. So the junctions, the devices, the pipelines themselves, the pipe itself is going to be modeled and maintained inside the utility network. And then we're going to fuse in with that the information model for the ArcGIS pipeline referencing. So if you've been familiar and you've seen my presentations on the APR information model, you'll know that we create measured networks or measured routes inside of the geodatabase using a series of centerline objects and a series of calibration points on top of those. So both of these data models, or both of these information models, still pertain to the integrated solution. However, the big change, and this is where really the magic is that we replace the generic center line with the utility network pipeline feature class. So the utility network pipe now becomes APR's center line. So the cadence will be, I'll build my pipes, I'll add measures to those pipes, and I'll be able to define a network or an engineering route on top of those pipes based on those begin and end measures. And then I'll be able to add to that both fittings that are in the utility network and connected to the model, as well as linear events that will ride on top of that pipe. A good example of a linear event might be my class ranges, class 1, 2, 3, 4. A good example of a fitting or a device might be a pipe or a T or a flange, right? So that's how we're going to do the sorting hat and make sure everything goes into the model correctly. But if you were to open up a pipeline data model like UPDM, like the 2018, now the 2019 edition, soon to be 2020, you will find those core information models inside of here. Right? So if you look closely, you'll see the pipeline referencing model sitting inside the integrity. You'll see the domain assets sitting inside the oil and gas network and the structure network. So these core information objects sit inside the much larger data model. Right now, ArcGIS pipeline referencing is inside of pods, but we're also now working with pods to add utility network functionality to that as well. So in the coming releases of pods and the coming releases and the current release of UPDM, we have the ability to support those industry standard data models. But there's nothing really preventing you from taking these core information models and moving it into your own custom schema. So don't feel that to use APR, to use the utility network, I have to move to pod 7 or I have to go move my data to UPDM. You can take those core information models and you can build your own data model around them. They are just the core objects that connect pipes together and allow us to do linear referencing, dynamic segmentation along those pipeline segments. So let me take you through a couple of things that will now that I've got those two technologies fused together, some of the things that I'll be able to now do inside my linear referencing system. The first, and I kind of mentioned it earlier, is to be able to build a rule base or network rules. So these rules define what type of objects can connect to each other. So what type of junctions connect to other junctions, what kind of junctions connect to my pipes, what kind of devices can be contained inside of other devices. So a rule might be, hey, if I'm going from a 12-inch to a 14-inch pipe, I need to have a reducer in between. Or if I might have a rule that says you can't put a mainline valve inside of a pump station, right? These are all business rules that you can then build into the network that allow you to maintain data quality as data goes into the GIS. I talked about this idea of containment, right? So now I can now drill inside of these objects and do more and more detailed mapping. So inside this pump station, for example, I can go inside and now start mapping out the internals. I can still represent that pump station on the maps as a single point, but then I can open up those single points and then dive into more details inside of that. The other important topic for the utility network that we're bringing to this is the idea of these terminals, right? Or to be able to really give intelligence to these devices as we place them. So now as a device goes into the GIS, it's not just simply a point on the map, but it has rules and it has connectivity to how that device fits into the overall network. And so some of those rules might be, what is the high pressure? What is the low pressure? So say a compressor or a pump would have those type of terminals associated with it. Maybe some are bidirectional, like a valve, right? So you have an inlet port and an outlet port that you would then bolt into the pipe on either side of it. Some of them might only be able to allow flow in one direction. A check valve is a great example, right? And so when I place a check valve now, I can only flow in one side and out the other, and product can't flow backwards. Why is this important? As I start building these smart objects into the network, I am by in turn defining my characteristics of my network. So no longer do I have to maintain a separate ranged event that says these devices are connected together or the pipeline flows in this direction. The devices themselves have intelligence, and that intelligence then comes through. So once I have those devices and once I've wired them to the correct pipelines correctly, I can now do some interesting things with what we call a subnetwork. And a subnetwork is basically, I think of it as a persisted trace. It tells me, for example, if I'm looking at the pressure tier, all the things that are connected in and that see the same pressure. Or if I'm looking at, say, an isolation tier, I'm looking at all the devices and all the pipes that would be connected if I need to shut off a valve, two emergency valves, what would be isolated for the system. So the important part of this is that these subnetworks are really driven by the data. So as I add a new valve, I would create a new isolation network. As I add a new pump to the system, I would create a new pressure system. As I add a new meter, I would create a new system of how those things are connected together. So driving from those devices, I now have this basically building a hierarchy within inside of my GIS. And this is how we're going to attack this in the integrated solution as well. We're going to use the utility network hierarchy and then drill down into the linear referencing routes on top of that hierarchy. And then once I have everything connected together, then I kind of turn on these advanced analytics. I can do tracing. I can see exactly what's connected together. I could theoretically trace from the wellhead all the way down to the delivery point and see everything connected in between. So I have a lot of different use cases that I can use this for. I can look at pressure zones. look at the maximum minimum operating pressure of all the devices connected to a pressure zone. I can see exactly where my isolation zones are, whether they be primary, secondary, or emergency isolation. I can do CP tracing. So not only do I see all the devices that are connected together under pressure, but I can see all the devices that are cathodically protected. What sees the same CP influence zone? Again, based on those objects that I placed in the GIS. And then finally, be able to look at that in an alternative view, right? Take these networks now, take this layout, say a pressure system, and then generate a diagram from that pressure system and be able to publish that out to the rest of the organization. So lots of different layouts that I can apply. I can even create my own and give more logical views to what's going on inside the pipeline network. So with that, I'm going to flip over to my desktop and we'll take a look at how some of this actually works. So this is my combined data model. What this is behind the scenes is a single enterprise geodatabase. It happens to be based on the UPDM structure. I've created a set of services and I've published those services out to my portal. And then I've consumed those services back into my desktop. So if I was to look at my connections here, you'll see really quickly I have some local files that I'm using for support. I've got 2 services connections that I'm primarily using. One service has all my combined utility network and APR layers that I'm going to use. So this has the networks, the pipes, devices, and the pipelines. And then the other one has those linear events. And I just happen to break these out into 2 services. You could have them in one, but this is a service that I'm going to use with the event editor and supply information from a linear aspect back on top of the model. But both of these services are published out through our enterprise server, and they're pointed back to the same enterprise geodatabase. So in this particular example, what I did is I started first by building the pipes. As I said, the basis of this model is going to be the pipes themselves. And so what I've done is basically the blue lines there are the pipelines from the utility network. And the pipelines are broken into a couple of different components. These happen to be the transmission lines here, but I've also got some gathering pipeline up in the north and some distribution pipe down here in my tank farm. So now what we're seeing is the what we call the asset group and the asset type inside the utility network. So I can split my pipeline down by how they operate. But the second thing I did is I started layering in some of those objects or some of those devices along the line. And the first thing I did is I wanted to create my systems. And in this case, I have a rule that says that the start of a system is where my meters are located. So I've defined my meter locations. I've given them a name. I've connected them to the pipe on either side. And once I did that, the system automatically found the upstream and downstream meters and built that system layer for me. So now if I look at my subnetwork, I can actually see those systems. So you can see those lines broken apart. And if I open up the table of contents, you'll see them a little more clearly here. So you can see I've got them named by how they flow from each system to each system, broken down. So again, if I was to add a new meter device halfway through this line, this system hierarchy would automatically change and adjust based on where my meters are located. Now from there, I want to take it down to the next layer. So I'm going to open up my devices here. The next device that I created along the line were these pumps. So my pumps are now going to describe where my pressure systems are. So everything between pumps is connected together. I've defined each of these pumps to have a name and how they're connected to the downstream section. And so when I go back to my hierarchy, when I go back to my sub network and I'm gonna look at my pressure systems, I can now see another logical breakdown. Again, as I add new pumps. They'll be contained within a system, and each will have its own pressure system associated with it. And then, as you can guess, the next layer down, if I go back to my devices and turn on my valves, are going to be my isolation sections. So now that I can see all my valves along the line, I can see, and I've defined those valves as being isolation valves. And let's just zoom in a little closer. I can now see all those sections along the line that would be isolated if any of these valves were turned off, right? So this is a summary object of all the pipes and all the fittings underneath that are connected between these mainline valves. And this is really where we have the jumping off point to start the linear referencing system, because these are all connected. This system is fully connected behind the scenes, but now I want to define a linear referencing system between my mainline valves. So the way that we did that is we went back to the actual pipes themselves. And if I open up the linear referencing group layer here, I can turn on my engineering networks. And let's go ahead and turn on some labels. And I can see now that I have an engineering network associated with each of these mainline block valves to mainline block valves. Now, obviously, over time, as I do reroutes and replacements and repairs, I might have more than one line or more than one route inside of here. But right now, I'm zeroing at these mainline valves, and I have a continuous measure that runs down to the next valve, right? So those are my mainline valve sections. And if I zoom in a little closer here, and turn on my measures, you can see the engineering measures on top of those lines. So here's my mainline valve. If I turn on my calibration points, you can see the 0 + 0, 0 of this route and the back station 2385 of the previous route. So now these lines, this route line here, has been calibrated to the underlying pipes. So instead of having that simple pipe center line underneath now, I select this, this is actually my pipe layer from my utility network. And if I'd open it up, I would see all the attributes about that pipe layer, whether it's piggable or not, what the diameter is. You can see operating pressures, GPS accuracy. These are all the information coming from the pipe, underlying pipe itself, and then with the linear referencing system set on top of that. With my linear referencing system set, I can now add in all my linear referencing layers. So these are all the layers that are tied to measures along that system. If I turn this on in this area, I should be able to see some DOT class. Turn off some of this labeling. So I've got a class 3 area. This is a linear event now sitting on top of those pipes within that area that is defined on these by its from and to measure along that pipeline. So now what I want to do is I want to show you sort of how these things are connected together, right? So I talked about those pumps and I talked about those devices. Let me move back here to one of these pump stations and take a little closer look. So remember, because my linear referencing system is set up to live on top of those pipes, I can control where my linear referencing system stops and starts. So here's a very simple station. I have a linear referencing system, but I've got some additional pipe here that is outside my traditional linear referencing system. So we would consider this pipe inside the fence. So I can still manage and model my pipe inside the fence. I can choose where I want to start and end my linear referencing system. In this case, we started and ended at the valve. And then I have some other objects within the station, and in this case, this pump. But I want to make sure this is all connected together. So one of those things that I can do in the utility network is connect objects together. So if I just select this pump here and show what its connectivity is, you can see the low pressure in. Remember I said there was terminals. So the low pressure of this pump is tied to that weld there. And now the high pressure out of this pump is tied to this weld here. So now I have linear referencing. My pipe, I go in and out of the pump from low pressure to high pressure. And I can also see that on the map. So there's my what we call our association view. So I can actually connect these objects together and have that fully traceable system going in and out of that, out of that model. Another example, if I go to another station along the line here, maybe I have a little bit more detail of what's going on inside this station, but I really don't know how it's all laid out geographically. So here I've got a pump station. So I've got a pump station object, and then I've got kind of a schematic view of all that's inside of here. So I've got 2 mainline valves, I've got 2 meters, I've got 2 pumps. And again, I've now wired all that together so I have my traceability through this station. So I come in through the T, I split off to this branch here that goes through this pump, and then downstream from this lateral, and then through this T and this set of devices onto this line and down through here. And again, if I turn on those engineering measures, right, you can see where I've got my engineering network stopping and starting here. So this is a 0 for this line, this is a 0 for this line, and this is the ending station here. All connected, all discoverable, and all contained within inside of this container. And if I want to sort of clean up the map a little bit, I can hide the contents of the container. What that will do is use a display filter to just show the point event and not all the details inside. So now my map has a very clean view of what's going on inside this facility. I don't have to sort of on the mapping side show all the details inside, but they're all there, they're all discoverable, and they're all connected. Now my third example really gets into the details of what we've been after, is how does this look inside of a sort of fully cooked facility, right? So here I have all the details of what's inside of this pump station, even in the details of what's inside of this building here. So you can see what I've done in the linear referencing system is I've created those linear referencing system to run in and out of my launcher receiver assembly. So I've actually created the 0 point to be the end cap of the receiver, and the end of this line to be the end cap, and the 0 to be here. But if I want to look at that from sort of a pressure and isolation viewpoint, let me turn the pipelines off. So you can see from an isolation viewpoint, my networks stop at these closed valves. I can also look at the pressure through inside of this system. So what sees the same pressure in and out of here, and what sees the same, what's belongs to the system. So the devices now control how this looks inside of these stations. Turn that linear referencing layer off. So now I've got all my pipe, I've got my engineering network inside of here with my calibration points. But you can also see I've got some details inside of this facility. So again, I can then take a look at what's going on inside of here. I can enter this container and take a look at the more details inside. And again, this is going to expose all the items that I have inside of this container. And again, I can see all the fittings and valves and how they're all connected together. Now, these are not in the linear referencing system. So I just basically was able to draw these pipes with footage and connectivity inside of the station without having to create a false route or create station values. This is all sitting in the pipe layer, but off of the linear referencing system. And so where did this information come from? Well, because I drew this facility, this detailed facility in 3 dimensions, I can pull up this data inside of Pro as well and see this all in 3 dimensions. So now you're seeing those same objects. The red lines are the transmission lines, the blue are the station piping inside of this facility. And if I go and take a look at what's inside of this building, I can kind of peel back the surface of this building and see all the facilities inside. Let me just turn off the surface here. And now you can see all those detailed fittings, and that's how I was able to build the utility network inside this facility. So now all those pipeline and devices that I have in the utility network sit directly on top of the objects inside of the 3D scene here. So really granular, I can really get down into the weeds of what's going on inside the station and see what's going on. Take a look at those objects. So now let me show you how we actually build one of these networks. So what I'm going to do is I'm going to go back to my gathering system, and we're going to show you how we build a pipe up there. So you can see I've already started building out some of this gathering system. So this is not linear reference. These green pipes are just in the pipe layer inside of the utility network, right? So these are all connectable. I can trace through all these objects and trace into the transmission line. And if we get a little closer into the end of the transmission line here, if I just turn on those associations again, you can see how all the endpoints of those lines are all connected back to the start of the transmission system, go through their meters, through their pump, and down into the transmission system. I can see where the engineering measures start for my transmission system. See, it starts here at this mainline valve. There's my 0 point, so I've got some pipe here inside this facility down into the transmission line. What if I want to add to this gathering system? Well, if I just want to add to the pipe, to the network, I can simply bring those objects in from another layer. And in this case, I've got a shapefile that I received for this gathering system. And you can see here, I've got this sort of mainline trunk line that's in this gathering system. So I'm going to go ahead and bring this mainline trunk line over. I'm going to add it to the utility network. So I'm just going to go to the edit toolbar. I'm going to go ahead and select that line. And I'm just going to copy and paste that into my gathering pipe layer. And now if I just turn those supporting layers off, hit clear, I've got that new piece of pipe from that shapefile in the utility network. We're going to go ahead and select it and set some attributes on it. The one that's really important is it's already in the asset group, which is pipeline gathering, but I'm going to give it an asset type. Let's say it's coated steel. And then I could go through and fill out all the attributes about this pipe. OD, wall thickness, manufacturer grade, all the business objects are associated with that. I won't do that for this example. We'll just leave it as a basic piece of pipe, but it's now inside the utility network. If I go ahead and validate that, we'll see if we have any errors on that pipe. It should come back cleanly. Validating the topology for that line. And it's successful. So that line is now in the network, but it's not connected. If you look at the end point of this line here, it comes up just a little short of where that connects into the rest of the network. So I can do a couple things. I can add a piece of pipe here. I can move this vertex down and connect it, Or maybe I can add a couple of objects here to show you that connectivity. So I'll do that. I'm going to go back here and let's create a T. And again, I'm going to create a metal three-way T. And I'm going to put it right here on that pipe. And let's add a weld at the end of that line. Put that there. Accept that. Just do a quick check here, make sure that validates correctly. Looks good. So I've got those two devices now sitting on the line. One thing you notice is I didn't have to break the pipeline to put that T there. So junctions can sit on top of the pipe itself. It doesn't have to necessarily break the pipe. And this weld that's at the end. And then I have a rule in the database that says I can connect a weld fitting to a T. So I'm going to do that really quickly. I'm going to go into the modify here. Modify connectivity. You can see the weld is automatically selected. It was a selected object. I'm going to add this T as my junction. Apply that. And now if I look at the connectivity in the model, I can see that those are together. And if I really wanted to double check it, I could do a quick connected trace by just adding a start point here on this line. And then I'll just run a connected trace on this really quickly. There we go. So you can see that it's highlighted everything that's connected to this starting point. And if I zoom out, you really see the power behind this. It's connected to that line, which is connected to this point over here, which then gets into my transmission system, and then all the way down. So that line is now fully connected in the model. Now, obviously, I can run different traces like isolation traces to stop at the next pump or stop at the mainline valve. But this shows you how quickly I can see that everything in the model is fully connected together. So that gets me into my pipe. So my pipe is connected, it's created, it's in the utility network, but maybe this is a trunk line. So maybe I really do want linear referencing to happen on this line as well. So how do I do that? Okay, so I have my pipe. My pipe is my center line for linear referencing. One requirement is I do need to have my begin and end measures on my pipes to begin the process. So in this simple example, what I'm going to do is I'm just going to figure out how long this pipe is. So I'll just go in US feet and just grab that objects. So that pipe I added is 104,996 long. So I'm going to use that as my my begin or my end measure for this particular section of pipe. How do I do that? I'm just going to select on that pipe object. I'm going to go into the attribute table, and inside of the pipe down below here, you're going to find the begin and end measure thing I'm going to use to create this route from. So remember the initial calibration points are going to come from my pipes. So let's put in my engineering from measure as 0. And my engineering to measure is going to be 104,996. Hit apply. Now I have my pipeline center line. I have my begin and end measures set. Now I can go to my location referencing tool. I'm going to hit create. I'm going to select that center line. There it is. I'm going to tell it I want it to be part of my engineering network. And you can see it's automatically reached into that pipe record and pulled up my begin and end measure. I'm going to tell it this route is available today. I'm going to give it a line name and a route name. And now that has created the linear referencing system on top of that networked pipe. So now I can use that network pipe. If I zoom in here, you'll see it's completely measured. So I've got all my measures. You can see all my vertices are all now measured. This particular example, I happen to show every 500-foot tick along the line. Now, if I then wanted to add further calibration points to this line, I could just do that by using the standard location referencing tools. So let's just kind of add a quick point here at this vertex, and let's call that 68,850. And I'll run that. And if you watch those station ticks, you'll see everything shifted over. And now I have those new measures on that route. There's that new calibration point. So now from here, I'd go ahead and if I was in a version, I would save this version, reconcile it, or just pull up this data in my event editor. So now that I've had that line in my system now, it now shows up as a new route inside my event editor, and I could go ahead and start adding all my linear events along that route inside of here. Let's just do a real quick one. Let's add a quick point event. Let's say an inspection note. And let's put it at this measure here. Save that, and now I have a new event on that line. I could go back into Pro now, refresh my version, and be able to see that line on the event. So that's how we would add events on top of the linear referencing system. If I want to add other fittings like flanges and valves, I could just do that directly here in the utility network. Now, the last example I wanted to show you, this is great at a very high level. You know, I have one big piece of pipe, but what if I really wanted to get very detailed on my mapping? What if I wanted to really get to that next level and map the individual joints of pipe from my system? So in this example, what I'm going to do is I have another area where I did an as-built for a small reroute. So this particular example, what I did is I brought in a number of survey points. So what these survey points represented was the individual shots on the individual welds from the surveyor. All right, so I've got my 8 individual joints here. These happen to be 80-foot joints. If I just select one of these survey points and kind of look at the attributes, you can see I've got the X-ray number, I've got the engineering station of that particular point, what it is. So there's a 0 plus 1 plus 94, 2 plus 78. So those were the individual points that I received from the surveyor with their measures. I simply took those points and used them to connect the dots. So again, this is the pipe layer. So I'm seeing the individual pipes now, or the individual joints of pipe along that segment. And if I click on the attribution, you can see I've got all my attributes filled out, whether it's piggable, what type of seam type it has, you know, all that same stuff that I filled in at the very high level, I can do it on these individual segments. But now what I want to do is I want to use these individual segments to really build up my route in this area. So let me go ahead and shut off a couple of lines here. Let me clear that selection. Let's just move this over a little bit. So there I've got all my individual, remember I've got all my individual sticks of pipe there. I'm just going to go ahead and select those. I'm going to drop out the existing pipe. I don't want that. I just want my new pipe. Again, I'm going to go back to location referencing. I'm going to hit the create tool again. And this time I'm going to have all 67 pieces of pipe selected. So now it's going to go down through and it's showing me the connectivity of all those joints of pipe. So there's about 87 different joints in there, all connected together. I'm going to go and put this in my engineering network. It's automatically going to find my begin station and my end station for this segment. Again, let's give this a date. And let's run that. And I've got one pipe out there that didn't match. So let's try to see where that is. So this is what it's going to do as a QA/QC tool for you. I'm just going to look at a couple of these pipes here. I believe it's right in this area. So I'm looking at my begin end station. So I'd find my begin end station where it didn't match. I've actually got this in a version. Let me just switch to it. So I'd fix this in my version. So I found where that mismatch is from the surveyor. I had fixed that up. So let me just make that selection again. Got those pipes selected. I'll go back to the create tool. Again, we'll see all those vertices. This one now has that end station cleaned up. Go ahead and put it in my engineering network. There, it completed successfully. And now I have my linear referencing. So now you can see where every weld is now. I have a control point or calibration point along that route. I've got all those pipes underneath, all tied together inside of a single route record inside of that line. Now, when we think about that in terms of integration with other systems, I now have every weld placed along that route. I have a route object. I can go in and start, say, mapping anomalies by welds and weld and offset. I can also now go ahead and start putting my other fittings on this line, my bends and my mainline bends and my valves and all the things. As I place objects in the utility network, they'll automatically pick up the stationing from the underlying linear referencing system. And as I add objects in the linear referencing system, they'll automatically be connected to the underlying pipes inside the utility network. So we fit a lot into the demo today. There's a lot more to show you. We also have sort of the schematic views that we really didn't get to today that we can talk about as well. There's a lot of going on in the utility network. This full demo takes me about an hour and a half most days. But this is really showing off the power of how we have both these systems connected together and running inside that single enterprise geodatabase. Tom, do we have any questions out there? I know we got about 10 minutes left.
Yeah, well, many thanks, Jeff. I mean, just a whole lot of really good points in the demos. I mean, they were really very impactful. There's also a lot of questions. I'm sure more questions than we possibly can answer here in the time remaining, but let's take a run at some of them. There were a number of questions about, could you elaborate on the use of these capabilities with pods? Do you want to take that one?
Absolutely. So right now I'm heading up a working group with inside of pods, and basically what we need to do is we need to get the utility network information model or structure into the pods database so we can then support all this networking capabilities. So we hope to have that done in the next couple of months, 6 months, 8 months max, and that will allow you to have this combined editing experience inside of pods as well as we have it inside of UPDM today.
Okay, so Esri really is agnostic, which I think was the point of your one slide, correct?
Correct. Yep, as long as we have that basic underlying structure, whether it's pods or UPDM, the same functionality exists.
Okay, and how about smaller organizations that use file geodatabases? Will these capabilities work for them?
Almost. The utility network at 10.8 now supports a file geodatabase. APR still, for creating routes and calibrating routes, still uses can use a file geodatabase. The piece of the puzzle that we would be missing would be the event editor, like placing those linear events and point events along the routes. That actually requires the portal. You can actually wire that up to an enterprise, to a file geodatabase and get it running. Obviously, it would be single user mode. So it is possible, but that event piece is the kind of trickier config. And if anybody has that use case, simply reach out to us. We can give you more details on how to make that work.
Okay. A number of questions about Z values, how they're handled by these capabilities.
Yep. So basically the pipe itself can have X, Y, or Z. So in this particular example here, you can actually see it. I didn't make Z's for everything. My Z's for my regular pipe still at 0, but this pump station we drew at elevation so that when I overlaid it with the imagery in the surface, then everything lines up correctly. So anything in the model can be drawn with XY or XY and Z, and then measure is the fourth component that can be layered onto that.
So Z is available throughout both the utility network and APR?
Correct. And really what's controlling the Z value is the pipes. That's where it all starts, right? So my vertices on my pipe now have Z values. And then as I then add measures to those vertices, I pick up that fourth dimension. So X, Y, Z, and M for all pipes.
Got it. Thank you. I know you mentioned we didn't really get to the schematic capabilities of the two, but we actually have a number of questions about schematics, diagrams. Could you give a brief answer and maybe we can follow through with more later then?
Yeah, absolutely. So what we did here is we actually used that pressure system. So I simply did a trace on a pressure system, which then selected all the devices within these two pump stations. And back here inside of back here inside of the utility network, once I've selected those objects, I can then create a new diagram. And then inside the diagram pane, I have a whole bunch of different options of how they get laid out within the tool. I just happen to use a straight line diagram here, but I can then label. I could label pressures, I could label valve IDs or pump IDs along this schematic, and then share that out with the organization.
Okay, cool. And you mentioned UPDM 2020. Any idea when that will be released?
So the work is done. The solutions team is now taking all the input from all our customers, myself, Tom DeWitt, and sort of bundling that into the updated data model. We had targeted around the UC timeframe. I know COVID has kind of put us a little bit behind on some of this, but certainly I would hope by mid to end summer we'll have the 2020 model. Not a significant change to the structure. So if you're looking at UPDM in 2019, 2020 is going to be, I consider it more of a maintenance update where we're sort of adding and tweaking the model, but the major changes to the infrastructure to support this have already been done in the 2019 model.
Okay. ILI data. Could you briefly talk about how that can be used in the networks?
Absolutely. So the way we kind of see the ILI data, obviously now that I have each of those individual welds and weld locations, as I showed in that reroute example, or if I just have my major segments, we would foresee those linear objects for the ILI all being linear events along those lines. So the ILI ranges, the anomalies, the groups, the reference markers, those would all be points along the line. If I just jump over to this sample really quickly, I have some ILI data loaded in here on the linear referencing system, and I can just basically overlay that linear referencing data onto the line. So here you can see all that ILI data lined up on top of that, sitting on top of that pipe in the utility network, aligned to the APR.
Super. Thanks, Jeff. Well, I do want to be mindful of the time. We are very, very close to the top of the hour. So let me please thank everybody for joining in today. We really do appreciate your interest and your willingness to share some of your time with us. Unfortunately, we didn't get to all of the questions, but we do have them, and someone from Esri will be following through with you to answer as many of those as we can. So thank you again for joining us, and have a great day. Bye now.
Bye now.